change in free energy of reaction under standard conditions of the following reaction in kilojoules per mole. And it tells you that F, which is the Faraday constant, equals 96,485 coulombs per mole of electrons. Well, the equation that we're looking for here is that delta G naught reaction equals minus NFE naught cell, where F is the Faraday constant, N is the number of electrons in the redox reaction, and we can figure out based on the oxidation and reduction half reactions what the standard cell potential will be. To do that, of course, we have to go to our SRP table. We can see that magnesium is being oxidized. That potential will be positive 2.37 volts since it's being oxidized, the reverse of the way it's shown here. And part of me being organized is I write out the oxidation half reaction. I write out its potential. I can see that my cobalt, 2 plus to cobalt solid, if I look at this list for a cobalt one, cobalt, there we go, 2 plus 2 electrons goes to cobalt solid. Minus 0.28 volts right there. Our electrons exactly cancel. We could write our overall reaction, but what we need is our overall cell potential. 2.09 volts. Now we can plug this into our equation here. We now know that our N is 2 electrons because we watched it cancel out. We know F, which is our Faraday constant. So we have 2 electrons. We have 96,485 coulombs per mole electrons. And we have 2.09 volts. And that converts this, if we know that 1 joule equals 1 coulomb volt, because we're going to have units of coulomb volts here. So coulomb volts, and that's a tricky proposition, but it is true. Anyway, so if I multiply this out, I get minus 4,307 joules per mole, where my joules come from coulombs times volts, and my per mole comes from my moles of electrons here. And you're being asked in kilojoules per mole, so we now have to move the decimal point 3 places, and 3 sig figs is always fine. Negative 403 kilojoules per mole. This is a very spontaneous reaction. Any questions about it? Sort of what we're doing is we're tying cell potential for spontaneous reactions back into free energy to show you that cell potential and free energy are really 2 ways of looking at the same thing. Cell potential is typically used for redox reactions because measuring voltages is relatively easy for redox reactions. Delta G is the free energy, is typically easier to measure when the reaction has a large change in delta H and or delta S. So when heat is given off, we typically think of delta G, given off or taken in. When electrons are exchanged, especially in solution, but not necessarily. Anyway, there are two ways of saying, will a reaction occur?